Hey, Mr. Wigdahl here with a lesson on paper and pencil multiplication. I'm not actually using paper and pencil. I'm actually using a tablet and a stylus connected to my computer, but you get the idea. I got my friend Adrian Peterson here to help me show you how to do it. I'm going to show you two different methods. One method is called the all partials method, and that's going to be multiplying part of the problem and then adding them all up. So all the partial parts. I don't know if that makes sense. All partials method, and then over here I'm going to try the compact method. Now the compact method is exactly what it says. It's more compact, it's more efficient. It's the one that I always choose because it just goes faster, and I like to be efficient with my math. But the all partials method makes everything really neat and organized. So whichever one you prefer is what you should use. That's kind of up to you. So the all partials method. Let's say I have a multiplication problem of 24 3/10 times 6 1/10. Now when you're multiplying decimals, it doesn't really actually matter if you line up the decimal points like it does in addition or subtraction, but it just so happens that I did with this. So first thing you do in the all partials method, you're going to do every number times the other number on the bottom. I don't know if I'm explaining that right, but let's see if I can kind of draw it here with a little bit of, I'm going to do, let's see, I can do it this way. I'm going to do these two times each other, then these two, then these two. Then, once I have all those, I'm going to do these two, and these two. Let me show you what I mean. Go back to my purple color here. So, first I do 1 times 3, and that's 3. That was easy. Then I do 1 times 4, but this 4 is actually, I'm going to think of it as 40 because there's another place to the right of it. So 1 times 40 is 40. Then I got 1 times 2, but actually this 2, we're going to call it 200 because there's a 2 with 2 places to the right. 1 times 200 is 200. Then I do the 6, but this 6 has a place to its right, so it's actually 60. So 60 times 3 is 180. 60 times 40 is 24 with 2 zeros, so 2400. And then 60 times 200, 6 times 2 is 12. And there's 1, 2, 3 places for 3 zeros. 60 times 200. Ooh, I'm running out of space down here. You can see how the all partials method can quickly get kind of long. So then the last thing you do is just add these all up. 3 plus all these zeros is still just 3. 4 plus 8 is 12. I'm skipping over the zeros. 12, I put down the 2 and carry the 1. 1 plus 2 is 3, plus 1 is 4, plus 4 is 8. 2 plus 2 is 4, and 1 plus nothing is 1. Now, is 24 3/10 times 6 1/10 14,823? No way. If I do some estimating, I know that 6 times, what's easy? Let's call this about 20. 6 times 20 is going to be about 120. So it should be in the 3-digit range for the whole numbers. So I'm going to guess it's about 148 23/100. Now, to show you the actual trick of how you do this, what you want to do is count all the places to the right of decimals. So there's 1, 2 places to the right of decimals, and then you start over here and you go 1, 2, and that's where you put your decimal. That green's hard to see. I'll show you with the compact method. So that's an example of the all partials method, but look how much writing was involved. For Mr. W, it works, but it takes so long that I'm like, oh, I don't want to be be doing the all partials method all day. I want to go have some fun. So I do the compact method because it's fast. So here comes the compact method. I'm going to give you the same problem just so you can see the comparisons. 24 3/10 times 6 1/10. Okay. The compact method is just going to go 1 times 3 is 3, 1 times 4 is 4, 1 times 2 is 2. That was really easy. Then I'm going to use the 6, but this 6 I'm going to think of it as 60 because it has a place to the right of it. So I put a 0 placeholder just because I'm like starting out with 60. Then I can still just do my single digit multiplication. 6 times 3 is 18. Now I put down the 8 and carry the 1. 6 times 4 is 24, plus 1 is 25. Carry the 2. See that? 6 times 4 is 24, plus 1 is 25. Put down the 5, carry the 2. 6 times 2 is 12, plus 2 is 14. Now, I just add those up. 3 plus 0 is 3. 4 plus 8 is 12. Put down the 2, carry the 1. 1 plus 2 is 3, plus 5 is 8. 4 plus nothing is 4. 1 plus nothing is 1. Now look, I ended up with the same numbers, but of course, about 24 times about 6 is not going to be 14,823. So again, I'll use a color you can see better. I'm going to count over the places to the right of the decimal. So to the right, I got two numbers to the right of the decimal. So I count over, I start at the very right side of this number and I go 1 place, 2 places. And that's where I put my decimal. I don't know what color I used here. So the answer is 1. Do a couple more examples here. Let's say let's get some zeros involved. Let's say I had 32, this is thousandths, remember tenths, hundredths, thousandths, 32 thousandths times 41 hundredths. Now look at, my decimals aren't lined up at all, and remember that doesn't matter. But before I even start doing this, I can count how many places are to the right of the decimals. 1, 2, 3, 4, 5. So 5 places. So I know my answer is going to be counting over from the right 5 places. Now, for this one, again, I'm going to do the compact method just because it's faster, and that's just what I prefer. So 1 times 2 is 2. 1 times 3 is 3. 1 times 0 is 0. Is that 0 important? Not totally, but I might as well write it down. Then I go over to the 4, but remember, because this 4 has a place to the right of it, it needs a placeholder 0. It's actually 40. 4 times 2 is 8. 4 times 3 is 12. I put down the 2 and regroup that little 1. 4 times 0 is 0, but now I'm adding 1, so it's 1. Let's add these up, and I go 2. 3 plus 8 is 11. Carry the 1. 1 plus 2 is 3. And 1 plus nothing is 1. I should have put a plus sign. Now here's a weird thing. If you remember, we counted up 1, 2, 3, 4, 5 places to the right of the decimals. But my answer down here only has 4. If I start here and I count over 1 place, 2 places, 3 places, 4 places, I have to go 5 places before I put a decimal, which means I have to fill in something here. And I fill in a 0. That's not going to happen too often, but in this case, it did. Essentially what I'm saying is 32 thousandths times 41 hundredths. I'm taking less than 1 whole of 41 hundredths. So it's going to be smaller. Let me show you one more with a little more understandable numbers, because that's kind of an important thing to be thinking about here. Let's use half. Like if I said 10 and 32 hundredths, I'm going to take it times 5/10. Now, normally when you multiply, the number gets bigger, right? Because you're multiplying, you're making it bigger. In the case of decimals, if one of your numbers that you're multiplying by is less than 1, you're actually multiplying it times a part of 1, or a number smaller than 1, which means it's like taking less than 1 whole of this number. I'm taking less than all of 10 and 32 hundredths. In fact, I'm taking half, because 0.5 is a half, right? 0.5 is equal to a half. 0.5, I should say 5/10. So I'm actually taking half of 10 and 32 hundredths. Think about that for a second. So if we round it, we should say the answer is going to be about 5, because half of 10 is 5. But let's just see. So I'll solve it with a different color so you can see it really good. 2 times 5 is 10. I put down the 1. By the way, you already knew this, but I'm going compact again. 2 times 5 is 10. I put down the 0, carry the 1. 5 times 3 is 15, plus 1 is 16. Put down the 6, carry the 1. 5 times 0 is 0, plus 1 is 1. And 5 times 1 is 5. Now, could something that's close to 10 times a half be 5,160? No. Could it be 51 and 60 hundredths? No. Could it be 5 and 160 thousandths? Yes, it could. And if I count all my places, I'll underline them so you can see them easy. 1, 2, 3 places to the right of the decimal. I got 1, 2, 3 places. Oh yeah, I did that with waves, didn't I? Let me do it again like I've always been doing it. I did it like this. I start here and I go 1 place, 2 places, 3 places, and put my decimal. 5 and 160 thousandths. Okay, good luck with your own paper and pencil decimal multiplication. If this was complex, rewind it to the beginning and watch it again. Have a great day.